Today we're talking about compound inequality. Compound inequalities are inequalities that are joined by the word and or the word or. So for example, we have x is greater than or equal to -5 and x is less than or equal to 7. This compound inequality that is joined by the word and can be written in this manner. Do you see why? What happened here? Just put the x in the middle and switch these around. So now it reads -5 is less than or equal to x and x is less than or equal to 7. If we are graphing these, anytime we are graphing compound inequalities with the word and, the graph is going to join. So what do I mean by that? If x is greater than or equal to -5, it means this will be a closed circle and the line is going to the graph includes all the numbers to the right. But then x is less than or equal to 7, also a closed circle, and it includes all the numbers less than 7 or towards the left. See how the graph joins? Yeah. So this compound inequality includes all the numbers between -5 and 7. So let's try this one more time. If we have x is greater than or equal to -8 and x is less than or equal to 10, how can we rewrite this inequality without the word and? -8 is less than or equal to x, x is less than or equal to 10. How can we graph this? Okay, let's go ahead and graph it. -8, 10. Would they have open or closed circles? Closed circles. So if x is greater than -8, then to the right. And if x is less than 10, to the left. Now if we change the scenario and this is no longer a greater than or equal, it's just greater than, what happens? Now the circle, it's an open circle because it does not include -8. That means that the solutions are all the numbers between -8 and 10, not including -8. Right? So -7, -6, -5, -4, -3, -2, -1, 0, and 1 through 10. Does it include 10? Yes, those would be the solution to the compound inequality. And we can see them here in the graph. So let's write a compound inequality to represent all real numbers that are at least -2 and at most 4. What would that look like? All real numbers that are at least -2, so -2 is less than or equal to the numbers, and they are at most 4. At least -2 and at most 4. What would the graph look like? have to write a compound inequality for all real numbers that are less than -3 or greater than 7. So we would say x is less than -3 or x is greater than 7. When our compound inequality has the word or, we cannot join it. Well, let's see what the graph would look like. 7. Open circle on -3. Our graph would point to the right or to the left? To the left, because it's all numbers less than -3. So x is greater than 7, our graph would point to the right, all numbers greater than 7. Do you see the difference between a graph with an and a graph with an or? We have to solve this compound inequality. Do you see how this is what they share? Right? Okay. So what we have to do is we're going to write the compound inequality as two inequalities joined by the word and. So in other words, -4 is less than r minus 5 and r minus 5 is less than -1. With this word and, do you already have a mental picture of your graph? Yes. So what we have to do now is we need to solve both of these. Then we have to add 5. So 1 is less than r, and over here add 5, r is less than 4. And now we can graph these. So wouldn't this be the same as writing it as 1 is less than r, less than. Question. We need to solve 4b plus c plus 3 is less than -5 or -2b plus 7 is less than 1. Do we already have a mental picture of what the graph will look like? Yes. So let's start solving each of these. -3. 4b is equal to -8. We divide by 4. C is equal to -2. Or not equal. B is less than -2. Or subtract 7. -2b is less than -6 divided by -2. What happens when we're dividing by a negative? B is greater than 3. We have to flip the sign. So now we can graph. B is less than -2, or B is greater than 3.